66 million years ago, an asteroid struck Earth, causing the largest known mass extinction. Today, using cutting-edge technology, scientists have established a precise timeline of everything that happened on that terrible day. We know Earth is always at risk of meteorite impacts, but if an event like the one 66 million years ago occurred today, would we be able to survive? Join us in discovering the incredible events that nearly wiped out life on Earth millions of years ago. Imagine being in America 66 million years ago, specifically on the Yucatan Peninsula in Mexico, and looking up at the sky. A star brighter than the others catches our attention. We keep staring at it, not noticing any particular movement, but as hours pass, the star seems to become brighter. What we obviously don't know is that what we see in the sky is not a star, but an enormous asteroid about 15 kilometers in size, hurtling toward Earth at about 72,000 kilometers per hour. The impact with Earth is inevitable, but this is only one of the numerous destructive events that will occur that day and unleash chaos worldwide. For the first time, scientists have managed to establish a precise timeline of those terrible moments, made possible through high-resolution photography, computed tomography, and magnetic measurements of hundreds of meters of sedimentary rock recovered from the massive crater created at the impact site. Let's return to the moments before the tragedy. The massive asteroid approaches Earth's atmosphere and heads straight for Mexico, where the town of Chicxulub now stands. When an object travels at high speed, Earth's atmosphere behaves like water. Usually, smaller space rocks, called meteors, hit the atmosphere like pebbles thrown into a pond, quickly decelerating and burning up due to atmospheric friction, with only larger rock pieces surviving and falling to Earth. However, the asteroid targeting Earth 66 million years ago is mountain-sized. It strikes our atmosphere like a stone in a puddle, maintains its speed, and crosses our entire atmosphere in 3 seconds. The asteroid emits an enormous sonic boom that circles all continents in just a few seconds. The dinosaurs populating the planet run in terror, unaware of what is about to happen. Animals near the impact site are instantly vaporized. The celestial body falls at such a high speed that the air itself cannot escape its pressure and heats up instantaneously by thousands of degrees. This means that even before the asteroid touches Earth's surface, the scorching air vaporizes the shallow sea covering Yucatan. A fraction of a second later, the rock crashes onto Earth's surface. At that exact moment, a series of events begins that upheaves the planet. The impact of the massive rock is so powerful that the ground and rocks flow like fluids. The Earth explodes, and as if throwing a large stone into a pool, the initial splashes going in all directions are followed by a huge vertical splash. The first wall of Earth created by the impact rises over 32 kilometers high. The vertical spray of Earth is incredible, with debris flying into the air at 1,600 kilometers per hour, reaching over 8,000 meters high. In just moments, this mountain of debris collapses onto itself, leaving behind a huge ring that forms the crater. The explosion is so powerful it's like a billion Hiroshima atomic bombs detonating simultaneously. The kinetic energy transferred from the asteroid to the ground, rock, and air heats molecules to temperatures far exceeding the sun's surface. The heat strips electrons from atoms, ionizing the air into an expanding plasma ball over 10,000 degrees. The vaporized rock is ejected at hypersonic speeds. The rapid conversion of Earth to gas forms a massive pressure shockwave expanding outward at over 1,600 kilometers per hour. To better understand what happened, if this asteroid hit the same point on the Yucatan Peninsula today, the explosion would vaporize everything up to Texas in the United States. The shockwave would destroy everything up to New York, and the sonic boom would be capable of breaking window glass as far away as Buenos Aires in Argentina. The impact of the asteroid in Mexico was so powerful, it made the Earth ring like a bell. The waves generated in the Earth's crust at the impact site expand at 4 kilometers per second, activating faults on all continents, causing terrible earthquakes. 30 minutes after the impact, earthquakes of incredible power occur on the opposite side of the planet. The explosion gives rise to massive tsunamis as tall as skyscrapers. The first strikes the Gulf of Mexico's coast, with waves ranging from 200 to 300 meters crashing into what is now Mexico and the southern United States, extending tens of kilometers inland. The waves surge up riverbeds, creating walls of water up to 10 meters high. 6 hours after the tsunami, it hits the coasts of Europe, Africa, and the Mediterranean. Within 15 hours of the impact, the waves reach all the planet's coasts. If these events have already crippled much of the planet, the catastrophe is just beginning. The explosion has hurled tons of rock into Earth's atmosphere. Some fragments were ejected so forcefully they escaped Earth's gravitational pull, some even reaching the moon. However, most fragments are pulled back to Earth, creating a meteorite shower. Within an hour of the impact, the space-escaped fragments fall back onto the planet. Some are as large as buses, but most are marble-sized, streaking across Earth's skies at 300 kilometers per hour. These lethal projectiles hit fleeing dinosaurs and ignite fires, setting the planet ablaze. Most of Earth's trees burn. Animals that have survived seek shelter underground or in water. But the tragedy is not yet complete. The meteorite struck an area rich in coal and sulfur. The impact releases 100 billion tons of sulfur and 90 quadrillion liters of water into the atmosphere, which condense into clouds, unleashing a deluge of acid rain. But the global flood doesn't last long. The coal released into the atmosphere creates a layer of soot that overshadows the clouds and stops precipitation. It also blocks solar radiation. This soot layer remains in the atmosphere for about 3 years, with average planetary temperatures dropping by about 50 degrees. The world becomes a dry, cold place, and most of Earth's living beings go extinct. The only areas where the climate remains somewhat milder are the territories we now know as Madagascar, India, and Indonesia, which were tropical islands at the time. But where did this immense asteroid come from? Are there other rocks heading towards us? Using data from known asteroids, scientists have conducted a study that seems to have identified the origin of the terrible asteroid. The asteroid appears to have originated from the Oort cloud, a sphere of debris at the edge of our solar system. Researchers suggest that one of these debris pieces might have been pushed out of its orbit by Jupiter's gravitational field, directing it towards the Sun, where it fragmented into several pieces. One of these pieces then made its way to Earth and impacted our planet. Scientists believe such events are not rare and are destined to repeat over time, estimating a similar event every 250 million years. Such events pose a serious threat to our planet and our very survival. Consider that in 2013, the asteroid that fell in the town of Chelyabinsk, Russia, was only about 20 meters in diameter, but generated a shockwave that caused damage in 6 cities and injured over 1,000 people. For this reason, NASA has decided to undertake preventive missions to understand how to defend against these menacing space rocks. While Hollywood has accustomed us to apocalyptic scenarios where Earth is endangered by incoming asteroids, dealing with such an event in reality is challenging. Hitting a rock millions of kilometers from Earth, destroying it, or altering its trajectory is far from easy. After years of study and research, the DART mission in September 2022 attempted this epic feat for the first time in space exploration history. A probe was deliberately crashed into the asteroid Dimorphos, about 11 million kilometers from Earth, orbiting a larger celestial body, Didymos. The mission's goal is to understand if it's possible to divert an asteroid from its natural course. This is just the first test. Many more will be needed as there are many variables at play. But the goal is clear: to create a defensive strategy that protects us from threats from space. What other methods might we use to defend against unwanted celestial visitors? Let us know in the comments what you think and subscribe to the channel to follow our new videos. See you in the next story.